Dobar dan, Zagreb. Samo mala govor. So today's talk is about space and JavaScript and trust and many other things. My name is Denis Radin. You may find me online as a Pixels Commander. I work in a company, Focus Reactive, as a tech lead, and Focus Reactive is a senior-level React.js consultancy. We work with cool projects like large-scale React applications, high-performance challenges, and 3D applications built with React. Before we are going to talk about rules, how to write JavaScript code, let's talk a bit about rules of nature. And if you look around in our solar system and other galaxies and planet systems, then we may find that universe respects unification. All these planets, all the systems work by the same laws of physics. Unification is an effective method to decrease diversity. Aim for unification is to place elements in particular order, building strict system which is comfortable to use. And this is what we are doing as humanity. Every time we start something new, like some field of engineering or a field of knowledge, we start with a whole variety, with different sets of solutions, really crazy ideas, but then only best solutions actually survive. And it works for many, many fields we work on. Politics, economy, European Union is a kind of unification to make it more comfortable to travel and to trade, etc. And it works for engineering, of course. Unification never stops. Oh, for example, who can distinguish, is it a Boeing or Airbus? No. Huh? You think so? And this one? How do you know this? I mean, really, one of them is Airbus and another one is Boeing. And it's really, really hard to distinguish because the laws of physics are the same. And then with unification, with selecting the best ideas on the field, aircraft industry came to the conclusion that all aircraft are more or less unified in terms of how they look and how they work. And it's still a bit different for user interface engineering. We develop user interfaces for many years, but we are still in early ages. We are still doing a lot of assumptions. We still try to work with different technologies. So we might try doing this mental exercise and try comparing early ages of aviations with early ages of user interface development we are still living in. Yeah, this one is Microsoft Silverlight. It's a really, really weird ideas. Now nobody would try doing that. This is George's. Like Adobe Flash. What he was hoping for, like really. Yeah. This guy is so naive, just crazy. It's like not bad try, really like a Visual Basic or something. Java applets. So you see, humanity have all the set of crazy ideas how we should approach the problem initially, and it works for everything. And by the end, we unify the solution on the field, and we have less and less solutions. So for user interface development, we all see that web technologies are rising as kind of a standard for user interface development. You can develop for desktop, mobile, for the web, of course, which is a motherland of web technologies, and JavaScript and CSS. And once I was thinking, okay, what might be the next push for these technologies? We already can use them in so many places. Maybe this unification will get to the point that we can use JavaScript and HTML in aviation and to build aircraft instruments with JavaScript and CSS. I was like, why should we do that? Of course, I had just a lot of motivation by myself. I was excited by the idea. Wow, JavaScript on airplane. It actually happened then, but it's another story, I will tell you. The consideration was, okay, now we all live in the age of drones. And if you control a drone, it's really amazing to have all controls, all navigation and instruments to be available as a website. Like you open some web page and your drone, you have a whole control on your drone and all information. So why not? And the same you can put in a cabin, etc. So there are some benefits. Unification. So nowadays all these companies are building their software in different ways with a different set of libraries. There is some standardization, but still there is no one stack. And if we go with web technologies for these user interfaces, then we can get to unification, which is amazing because, another thing is, even you don't think about this, but browser is amazingly reliable. Billions of people are using browsers daily, opening billions of websites, hundreds of billions, and they don't crash. Maybe sometimes, but normally they don't crash. Once we got unification, we can establish some components market, which can boost the whole industry. Why not? It's very conservative, traditional industry, building aircrafts. Of course, it's a lot of responsibility, a lot of risks, but okay. Thinking about these points and having a lot of enthusiasm, I built the first ever aircraft instrument with JavaScript, HTML, CSS, and I asked my friend who had a personal airplane, man, let's fly using this instrument. Let's try how it works. And we've been flying over Amsterdam. It was on altitude of around 1,000 meters over this inner Z lake. Come on. We need you now. You know, this artificial horizon it was, like, which actually tells the pilot how the plane is located, how it's rotated, tilted against the horizon. And actually it worked. So we've been flying for a couple of minutes using this instrument, and it is definitely possible. Of course, there are some considerations. The biggest consideration is reliability, of course, and then memory efficiency, resources efficiency, and the biggest ever thing, if you're thinking about resources efficiency, is rendering. If you display any graphics, then you should display graphics in a very efficient way. And displaying graphics in an efficient way means that you should use hardware acceleration for that. It's the best saving on resources you can do developing user interface with some animations, etc. So it was nice. I was really happy with what happened, and my friend was excited even. Okay, let's consider a situation. You're flying to Berlin. You're taking your place on an airplane, and your neighbor is saying, hey, it's a JavaScript-driven airplane. Everything in cockpit is built with JavaScript by a web developer. Are you going to Berlin after that, or are you going to escape? it's what it says about the state of things, that how many of web developers are here who develop with JavaScript, HTML, CSS? You guys afraid of what you are doing, and you do not trust the things you develop. It's basically your trust in yourself as developers that, sorry, I'm not going to fly with my colleague code. And it's all about trust. And it's all about expectations of what is normal for a web stack. And it's pretty much clear where this situation is coming from, because initially what web page was. Even you have some problem on a web page, you hit F5, you refresh the page, everything is keep going. But it's not like that anymore. Like more and more complex things are being trusted to the web developers, and now we are challenged by another level of stability, and probably the perception of normal should be changed. Maybe with some more guidelines. And thinking about guidelines, it's really nice to consider this institution, Jet Propulsion Laboratory, on this photo, which is basically an institution responsible for missions like Voyager. Can your application run 36 years without a refresh? No, probably, but they can do that. And they also run missions like Curiosity, Pioneer. So basically everything which have years of autonomous flight, which was launched by NASA, was done by GPL. And once I was working on, it's a company called UPC. Do you have UPC in Croatia? Yeah, no? It's the biggest internet and TV provider in the world. I know for sure they're present in most of countries in Europe, but sure about Croatia. And we've been developing this operation system with JavaScript for set-top boxes. Like the box you connect to TV, you have some applications, and the whole operation system, the whole UI of the box was run with web technologies. We had our fork of WebKit, and we spent 4 years on optimizing it and making it more stable. It was quite interesting, challenging project, but the challenge as for stability was to run it at least a month without any resets, restarts, whatever. Like it should run a month. It's like it's just something which is connected to your TV. You don't want it to restart. And we've been looking around for something which could get us more stability, and we found this GPL rules for writing code. The rules are originally published. They are online. You can find them. It's not like rules. They are not interpreted. I give them just as is without any changes, but then we will try to extrapolate them to JavaScript a bit. With some approximations, because it's really hard to get C rules to JavaScript, but it makes sense. You'll see. So, rules. Jet Propulsion Laboratory. 36 years without bugs. Rule number 1, the simplest one. No function should be longer than what can be printed on a single sheet of paper. Sheets of paper sounds a bit weird. This is Margaret Hamilton, who is a lead developer, software developer for Apollo mission, which got human to the moon. And this is a source code for Apollo mission. So they've been operating sheets for a long, long time, developing a software for NASA. And okay, now we can interpret this. Rule number 1, do one thing in your function. Because saying keep functions short, it might be a bit too intrusive. But do one thing in your function, because long functions are harder to read, harder to compose, and harder to test. And there are many classic examples, and this one is about making coffee and cooking egg. And then if you put everything in one single function, it's really hard to refactor. You can't swap them, you can't make code asynchronous, and it's harder to reuse your logic. Do one thing. The second, Restrict all code to very simple control flow constructs. Do not use goto statements and direct or an indirect recursion. Here, the statement about recursion makes me a bit disappointment every time because recursion is something web developers need. But to apply any of these rules to JavaScript, the main thing to think about is what was the intent behind that. It's not like how it sounds, but what was the intent. And I was reading through articles GPL published, and the intent for this rule is to make code predictable. They rely on static analysis a lot. Static analysis is something like TypeScript. It's not about types, but like you do in runtime, you can predict some, in the build time, you can predict some errors. And for NASA, for tools they use, recursion is killing the predictability. But the rule number 2 is basically predictability. If code is predictable, if you can see what's going to happen and the whole idea is clear, then you have less chance for error. Rule number 2, predictability. If you want to write reliable code, drop to write cool one and write predictable. Define coding standard in your team and follow it. Because if you have the shared code style, probably makes a bit more predictable of what your colleague is going to do, right? Use static analysis on Git hooks to support coding standard and to reduce chance for defect. Many of you probably use already ESLint, but if not, definitely should. And pick as many plugins, maybe not forcing as many as you could, but there is always a common sense. But normally, I would say now ESLint is getting a lot of plugins on a project for checking many things. We will talk about this later. Collect metrics and analyze types with Flow or TypeScript. And TypeScript is actually winning now. I was working with Boss with Flow. It was like 2 years ago. I was trying it. And the paradoxical thing about Flow versus TypeScript is that even Flow is built with by Facebook, and React is built by Facebook. But TypeScript works with React better than Flow. I don't know how it happens, but TypeScript have really amazing support for many, many libraries, and Flow is lagging behind. I would expect that Facebook is going to drop Flow. So if you are picking static types for your JavaScript project, and you should if you write a large scale or if you try to get the level of quality, so go with TypeScript. Rule number 3, do not use dynamic memory allocation after application initialization, which is weird for JavaScript developers because any kind of memory allocation in JavaScript is dynamic, right? But and we are also relying on this memory management, automatic memory management. We relied on it so much that we stopped to respect memory. So we do not care about memory anymore. If you ask any JavaScript developer, okay, you have a data, and could you please tell how much of memory this data structure is worth? Like how much of memory it's taking? Nobody would answer you because nobody in JavaScript world counts kilobytes, even megabytes. I think even gigabytes are just getting rid of sense. If you look at this applications you run now, Slack, etc., it's getting a bit tough. But yeah, if you try to get to another level of quality, respect memory. Measure memory with DevTools performance tab and compare memory screenshots with DevTools memory. You know how to compare? Or how these tools work? Should we go to it, or who wants to see how tools on monitoring memory work in DevTools? All right, a few people are here. Okay, so the tab called Performance. It's if you're trying to analyze what's happening inside of your applications and why your application is actually laggy and janky and it's not pleasant for users to work with it and it's not smooth, then Performance tab is your primary friend, the main friend. So what you do, you open DevTools and a performance tab, and you start recording. So then you do, oh my God, I have only 10 minutes, guys. All right. And then you record with this button, right? And then you stop. And you got quite some insights of what's happening in your application. And this one, the blue one, is a memory allocation. And identifying the real problem the real problem looks like the memory usage is dropping. It means the garbage collection actually cleans the memory, but then it rises again to the more, so it never drops to initial level. And here we see the picture is quite healthy. So we see in these two drops, the garbage is being cleaned pretty much. So maybe there are some more allocation happening, but what really should make you cautious is that when every time it's bigger, and garbage collection is happening very often. Sorry, I don't have time for comparison, memory comparison. I should skip it. Maybe if you're interested, we can talk after. So respect RAM. Manage your variables with respect. Declare at the top of scope to increase visibility. ESLint vars on top plugin to put variables on top of your scope. Sort for predictability with sort vars plugin for ESLint. Watch for memory leaks. Clean listeners and variables when not needed anymore. ESLint, no unused vars. This one is really must have. No unused vars you should use in your project. Switch JavaScript to static memory allocation mode via object pooling. So in JavaScript there is no static memory allocation, but there is one thing which is very, very similar. Not completely, but then you can initialize as many objects of, for example, class user as you think might be used in your application, like maximum, like 200 users is going to be ever displayed at once. And then you take from your pool, you initiate them initially, right? So they are always in your memory, and then you just taking and putting back, So you never initialize new users again, you're just reusing 200 you initially created. Rule number 4, all loops must have a fixed upper bound. This also comes from predictability preference, and I don't think we can follow it more than just write predictable code. So rule number 5, the assertion density of the code should average the minimum 2 assertions per function. Assertions are not unit tests. It is something which looks for application state in runtime, but we can tell, okay, test well. And higher test density is less defects you get. Minimal amount of tests is 2 per function. Watch for anomalies in system state during runtime. Generate and handle errors in case of critical failures. And measure coverage, but be aware that 100 coverage doesn't necessarily mean you have well-tested code, because coverage is not a qualitative but quantitative metrics. Rule number 6, data objects must be declared at the smallest possible level of scope. This one is a well-known problem your framework is solving for you. So this is a problem called mutable shared state. And if you have mutable shared state, it's really hard to keep different parts of your application in sync. But yeah, if you use Vue, React, or Angular, or thanks God I don't use it anymore, Backbone, then you should be safe there. For React users, you may use ESLint Pureness plugin to analyze reducers. Rule number 7, the return value of non-void functions must be checked by each calling function, and the validity of parameters must be checked inside each function. So here, what GPL says about this rule is that it's been violated the most in NASA, working on spaceships. So if they do it, we skip it. Rule number 8, the use of preprocessor must be limited to the inclusion of header files and simple macro definitions. This is, of course, about C preprocessor, but we do a lot of preprocessing also in JavaScript nowadays. Babel, and then we have bundling, like Webpack. It all have some cost. Oh, this project is tracking the performance difference between ES5 code and transpiled ES6 code. Then we see that some functions are 17 or 50 times slower when you transpile with Babel. And it's not a big problem nowadays. It's getting better and better. Like a few years ago, it was all red and yellow. But you still should know that there is a price of transpiling and bundling. And here you see different tools for bundling. They all have different, first of all, the size of a bundle, and then compilation and execution time. Once you loaded your JavaScript, you need to execute it. And all these bundlers, they add some cost. So if you want to develop some top-notch performance system, you might think about avoiding bundling at all. Rule number 9, the use of pointers should be restricted. Specifically, no more than one level of the referencing is allowed. Function pointers are not permitted. For JavaScript, where pointers is everything is a reference, it's really weird, but it comes from the fact, okay, less pointers we have, then less mess we have in code with calling something. So we can make calling a bit simpler, reduce call chains. If you have a few call chains in your code, then you can create another variable and use it for mimicking call chains. And then lower Dimitra is put more responsibility into classes and less responsibility into high-level APIs. Then, yeah, you need less control on a high level. For example, if you have an object of class dog, then you don't do dog body legs run, but you just say dog run, and it runs. And the main rule, the last one, all code must be compiled from the first day of development with all compiler warnings enabled. But for us, it's pretty much often happens like, we have a small project, let's kick off, and we deliver in 2 weeks, then nothing happens, no tests, nothing. Let's deliver the shit quickly. And then this is basically a source where this expectations from web development is coming. Let's just deliver something. It should work. No problem. Refresh, F5. And here is where we fail. We fail and we drop our trust in ourselves. Because sometimes we deliver shit. And this rule sounds like, okay, compiler warnings for C code, but for us it may sound as take your project seriously. Try from the first day, think about the future of a project. At some point it will grow, probably. Most of projects actually you work, it's not 1 week thing, okay? If you develop a small website, it is, but normally you keep working on it for months and years. And take it seriously from the beginning. Take your job seriously. But what if you already fucked up? Don't panic, prioritize, refactor, and piece by piece, add tests, apply team guidelines, and it's all going to be all right eventually. And if we do this, if everyone starts following best practices, it's not only about these 10 rules I took from GPL and applied to JavaScript, which was a lot of approximation, it was a lot of like guesses, and the intent is take your craft, take this engineering you do seriously, and don't let this F5 refresh paradigm hit the expectations from web developers. And if we do that, maybe one day, if not aircrafts, not that far, but who knows where JavaScript can get. I know that in Netherlands, there are companies who already do ship instruments with JavaScript. It's happening now, and I know that Volkswagen is doing some JavaScript UI for cars. That's it, guys. Thank you a lot.
Are there any questions?
Okay, great talk, by the way. I have one question. Why wars on top? So I kind of disagree, because it adds unreadability to the code.
Yeah.
Because if you put all your variables up top and not closest to the context of usage, then you introduce scrolling.
Yeah, might be. I agree. So at some point, it was considered as something very beneficial. I would just explain you what kind of constraints we've been working on. This set-top box I was talking about, it was totally 500 megabyte of memory. And once you start browser, this empty browser, it was 200 megabytes for browser. And then you have 300 megabytes left for everything else, like drivers, graphics, everything. And then we've been really taking memory seriously and just looking at all variables we are using in method. It was like, maybe we don't need something. Maybe we should remove something. I pretty much agree that for general development, this might be skipped. I agree with that.
Thanks.
Welcome.
Any more questions? Well, thank you very much, Denis. Can I get another round of applause?